Hi, my name's James Brown. The present work forms part of my master's project at the University of South Australia under the supervision of Alex Chatburn, David Wright and Martin Imig. So overall we found that meditation following training promoted motor memory consolidation. This was exhibited through a decrease in reaction time from training to wakeful test, whereas in the control group an increase in reaction time was seen from training to wakeful test. And this benefit afforded by meditation didn't support sleep-dependent memory consolidation. So we asked whether a single session of mindfulness meditation can promote wakeful motor memory consolidation, either through memory stabilization or offline improvements. Previously, Imig has shown memory stabilization using an explicit sequence learning task with experienced meditators. The present research aims to extend these findings by investigating meditation-naive individuals using implicit motor memory tasks and including sleep-dependent motor memory consolidation tests. 20 healthy meditation-naive individuals participated in our experiment, 12 male, 8 females, with an average age of 23.7 years. So first, participants completed training on training sequence A, followed by meditation or audiobook listening. Then were exposed to interference through sequence B, then a wakeful period test through training sequence A, and again a post-sleep test, 3 blocks of training sequence A. So the SRTT was our implicit sequence learning task, which involved the presentation of 4 hello boxes on a computer screen, spatially mapped to response keys numbered 1 to 4 on a modified keyboard, as you can see here. Participants were required to press the key that corresponds to the highlighted box as quickly as possible. So the performance measure was reaction time. 1 block equaled 120 trials based on 10 cycles of a second order conditional sequence. So the meditation group involved 10-minute technique involving focusing attention to the breath, whereas the control group listened to a 10-minute audiobook, both groups seated with eyes closed. So the Bayesian inference offered several advantages over null hypothesis statistical testing, in that Bayes factors can state evidence for null and alternative hypothesis, whereas p-values only reject the null hypothesis, and Bayesian inference suited our small sample size, among other advantages. So we used Bayesian inference to compare group differences across training, interference, wakeful and post-sleep tests, and Bayesian independent sample t-tests were conducted in JASP. So here is an overview of our results. So we have mean reaction time on the y-axis, comparing with training blocks, interference, wakeful test, and post-sleep test. So let's take a closer look at the results. So in training, the control group performed faster than the meditation. However, using Bayes factors, there's weak evidence for group differences between the start and the end of training. And from the end of training to the start of interference, we can see moderate evidence for group differences. So post-training meditation reduced the degree of reaction time slowing when interference sequence was induced compared to the control. And as mentioned at the top, there was strong evidence that post-training meditation enhanced wakeful consolidation. So the meditation group exhibited a reduction in reaction time from end of training to wakeful test, whereas the control group saw an increase in reaction time. Looking at sleep-dependent consolidation, there was no evidence for group differences from late training to early post-sleep tests. However, both groups exhibited offline improvements even after interference. And similarly here, as seen between late wakeful test and early post-sleep tests. So the present findings are consistent with Imig in that post-training meditation can support wakeful motor memory consolidation, and they extend Imig by exhibiting offline improvements in novice meditators and using an implicit motor task, as well as including a post-sleep test. So the goal of meditation is to focus one's attention. So it might be that attention control with meditation might support motor memory consolidation. Other interventions might share attention control, such as exercise, which might promote motor memory consolidation through attention control needed to maintain exercise. And similarly, goal-oriented cognitive tasks require attention control to maintain performance. However, future research is needed to verify if attention control is a process by which meditation promotes motor memory consolidation. So the present findings are in line with the idea that implicit learning exhibits wakeful offline learning, whereas explicit learning is thought to rely on sleep for offline learning, which might explain why offline learning didn't occur following sleep under these implicit learning conditions. There is some discrepancy. For example, exercise and rest interventions have shown offline improvements using explicit tasks, which calls for further research. So the present work, importantly, furthers our understanding of wakeful motor memory consolidation processes. So increased attention control after training reduces negative transfer to new task variations, so from training to interference, enhances wakeful but not sleep-dependent motor memory consolidation, and it's not required to have experience with meditation to see benefits through attention control.